Hello everybody, this is the Notes for Calculus. This is the first section, the second part, second video of the first section. So, what we've talked about is the idea of a limit when we're just looking at a graph or looking at a table. That was the first part of section 1. The second part of section 1, the first video, was talking about finding the limit when you're just given a function. So there was a couple of steps to do. You first plugged in the x value, and if you got an answer, then that was your limit. If you didn't get an answer, then you had to simplify the equation and then try plugging in the value again. And then if that didn't work, then you went to the graph. So that was for finding the limit as x approached a number. This part, the last part of section 1, is finding the limit as x approaches infinity. And the same thing will work as x approaches negative infinity. You can't plug in infinity. Okay? It's an idea of a number. So there's nothing to plug in. So we can't follow those same steps. So what we're really looking at here is actually just the horizontal asymptotes. Sometimes. There are some asymptotes that we're looking at. Sometimes they're not horizontal. So a way to do this for all functions is what I have up here. When you are trying to figure out the limit of a function as x approaches infinity, what you are going to do is, like it says, divide all the terms in both the numerator and denominator by the highest power of the variable from the denominator. So what I mean by that, looking at this first example here on the upper left, the highest power of the variable from the denominator is x. So we're going to divide every single term by x. Okay. Now, and then simplify this. So now what we're looking at here, let me move this over a little bit. What we're looking at is 8 plus 6 over x, and all that's divided by 3 minus 1 over x. So now we're going to take the limit as x approaches infinity. All right, so as x approaches infinity, this first term, and what we're going to do is just go term by term, but that first term, 8, it has nothing to do with x. As x gets really large, that term is just going to stay 8. Plus 6 over x. As these x values get really large, we're taking 6 and dividing it by a bigger and bigger number. 6 divided by 10 is 0.6. 6 divided by 1,000 is 0.006. And then it just keeps on getting smaller and smaller, but it's going towards 0. The larger the x value is, the closer 6 over x gets to 0. Divided by, the next term is 3 from the denominator. That has nothing to do with x. So as x gets really large, it stays 3. Minus 1 over x. Same idea. As x gets really large, you're taking 1, dividing it by a bigger and bigger number. That's going towards 0. Okay, I'm not saying it's equal to 0, but it just gets so close to 0 that when we add it to 8, it really does nothing. Or when we subtract it from 3, it essentially does nothing. And so here we go. There is our limit, 8/3. Okay, so you're taking the highest power of the variable from the denominator, dividing every single term by that power of x, and then simplifying. Okay, anything with a fraction where the variable is in the denominator, as the x value gets really large, that term is going to go towards 0. And so you can clean it up and you get your answer. All right, so now looking at this next example here, the limit of 3x plus 2 over 4x cubed minus 1. So we're going to take every term and divide it by x cubed. And it gives us this. When we clean this up, we have 3 over x squared plus 2 over x cubed. All that's divided by 4 minus 1 over x cubed. Now, we're going to take the limit as x approaches infinity. So, as the x values get really large, for that first term, we square it, it gets even larger. 3 divided by an even larger number, that goes towards 0. Plus 2 over x cubed. As x gets really large, that goes towards 0, divided by 4 minus something that is getting really, really close to 0. So what we have is 0 over 4, which is just 0. All right? So that should be our limit, and it is, but let's take a look at the graph. So this function right here that I just highlighted, that's what our equation was. We're talking about the limit as x values get really large, going towards positive infinity. So I'm just going to slide the graph over here, and I'm going to start zooming out. You can see the graph. What we're looking at is the y values as the x values go towards infinity, as they get really large. Okay, it's showing that it's equal to 0. It's not, but it's really close to 0. Okay, and just keep on going out. X values keep on getting larger. Now, 212 is not very large, but you get the idea. These y values just keep on getting closer and closer to 0. That's our limit. Okay, now this next example right here, we're going to do the same process, the limit as x approaches infinity, but we're going to be dividing every term by x. So we're going to get 3x squared over x plus 2 over x all over 4x over x just goes to 4 minus 3 over x. So we are looking at 3x plus 2 over x divided by 4 minus 3 over x. All right, so as these x values get really large, this term is going to go towards 0. That term is going to go towards 0. What we're left with is a 3x over 4. Now, if you look at just this, it's essentially a linear function. It's got a slope of 3/4. So what we have here is called an oblique asymptote. Okay, it's not a horizontal asymptote, it's not a vertical asymptote, it's just an asymptote. So as these x values get really large, the question now becomes, when we simplify this, the question becomes, what is this function in blue here, what is this function going to do as these x values get really large? Well, it's a line, a slope of 3/4. It's a positive slope, so that means as you read the graph from left to right, these y values are going up. As the x values get really large, the slope is taking this graph to larger and larger y values. So this answer is infinity. Let's take a look at the graph. Okay, so we're looking at this equation. Let me go back to the main window. Here's what a graph looks like, just a standard 10 by 10 view of the window. The question is, what's the limit of this function as these x values get really large? It's not showing it, and it shouldn't, but there is an asymptote right there in blue. That is an oblique asymptote. So the question is, what is this function doing? What are the y values doing as, let me try to move this asymptote back up. What are these y values doing as the x values get really large? Well, these y values are increasing. They keep on getting larger. The bigger the x value, the higher these y values are. So you can see this graph just keeps on going. The answer for the limit is infinity. The y values are increasing without bound as these x values get really large. We keep on zooming out. Let me get rid of that pen there. We keep on zooming out. You can see these y values just keep on getting larger and larger. The bigger the x value, the larger the y value. Okay. So now let's take a look at this last example right here. Try to block off the other stuff. We're doing the same thing. The limit as x approaches infinity. So we're going to divide everything by the highest power of the variable from the denominator. That's the x squared. So 5x squared over x squared is 5 minus 4x cubed over x squared just makes it a minus 4x over 3x squared divided by x squared is just 3 plus 2x divided by x squared is 2 over x minus 1 over x squared. All right, as these x values get really large, that term goes to 0. That term is going to go to 0. We're looking at a 5 minus 4x over 3. Again, we're essentially left with a linear function. So the question is, what is this function going to be doing as these x values get really large? Well, this is a line. It has a negative slope. So if we were to graph this, we'd be looking at this kind of line. As these x values get really large, these y values keep on decreasing, going in the more and more negative direction. So the answer to the limit, as the x value goes to infinity, this function goes towards negative infinity. Let's take a look at the graph of that one. All right, go back to the main look of the graph. So what we have here, you can see there's this part right up here. There is this parabola-ish type part to the graph, and then we have this part. So our question was, what's the limit as x approaches infinity? As the x values get larger, these y values keep on going down towards negative infinity, and it just keeps on going in that direction. As I keep on zooming out, you can see those y values just keep on falling. Okay, this is how we do finding the limits of these equations as the x values approach infinity. And the same idea works with negative infinity. Okay, as these x values go towards negative infinity, the y values are going up for this function. So our answer to that limit would be a positive infinity. It's the same thought process, same steps. All right, bye.